Okay, so now that we know how to form formulas for ionic compounds, which we're going to need to do, of course, the other thing we'd want to be able to accomplish is to figure out the name by just looking at that formula. Okay, so we know that the ionic compound is made of a cation and an anion. Okay, now the cation can be a metal with an invariant charge, meaning it's never going to change, like sodium, potassium, calcium, those ones we saw on the table. Or it could be one of those transition metals with a variable charge. So there's going to be a slightly different way to name that. We're going to include the charge as a Roman numeral in parentheses, or it could be a polyatomic ion. Okay, and then we're just going to use the name of the polyatomic ion. The anion can be a nonmetal, and we're just going to use the IDE nomenclature, or it could be a polyatomic ion, which we'll see as well, and there we're just going to use the name of the polyatomic ion. So let's just first start off with the simple ones. Let's start off with metals with invariant charges and nonmetals. Okay, that's a very simple way. All we're going to do is going to name the metal, the name of the metal, and then use the base name of the anion with the IDE stem change. Okay, so let's take a look at some of the ones that we either done before or a couple of new ones. Okay, we've got a formula of MgO. Okay, we know that Mg is the elemental symbol for magnesium. And when oxygen is an anion, we know it is called oxide. So magnesium oxide. Okay. We know that calcium had a +2 charge, nitrogen had a -3 charge, so that creates a formula of Ca3N2. And we would name that just like we named magnesium oxide, with the metals first, and then the anion's name, and nitrogen becomes nitride. Okay, and KCl, of course, that's potassium and chloride. Okay, now for these simple ones, it's always metal, then nonmetal, and the general rule is it's always going to be the cation first and then the nonmetal. As you'll see, there's going to be a few polyatomic ions that are all nonmetals. If they're a cation, we throw them first as well. Okay, what about those metals which we know can have multiple charges, especially those transition metals with those d electrons that can occur different oxidation states, meaning different charges. We are going to want to include that in the name because there can be more than one different compound. Okay, so what we're going to do is just like our previous example, we're going to name our metal first, then our nonmetal, cation, then anion. Okay, we're going to determine the charge on the metal cation from the anion charge, which typically we know. There are very few nonmetal or anions that can have different charges, and in this course there will be none. Okay, remember we have that common ion table in 3.4, and then as well as a polyatomic ion table, which we'll speak of next. And again, no different there. We're going to leave IDE on the end. So here we have our general scheme: metal name, charge as Roman numerals, and then the anions with the IDE if that applies. Okay, so as we said, we need to determine the charge on the metal, which can have multiple charges, from the anion's charge. And here's an example of one here for Au2S3. So that's a gold sulfide compound, but gold can have multiple charges, so we have to indicate what charge it is for this very compound. Okay, so here's Au2S3. So what's the charge on the anion? Well, we know sulfide is going to be a -2, or 2- ion. Okay, so what's the total negative charge? What's that mean? Well, there's 3 sulfide ions, 3 with a -2 charge, so overall that's going to be -6. Okay, so what's the positive charge have to be? Well, we know that this overall compound has to have a neutral charge of 0, so it has to have a +6 charge. Okay? Now, the next thing we're going to do, if this applies, we're going to divide by the number of cations, because that's the +6 charge for the total positive charge. We can see that there's 2 gold cations there, so each gold is going to be a 3+. Okay? So how would we name this? We would name it gold 3 Roman numeral sulfide. And so that Roman numeral 3 indicates that's the gold with a +3 oxidation state or charge. Okay, here's a couple more examples. TiCl4, titanium, another transition metal. Well, we know that chloride has a -1 charge, and there's 4 of them, so overall we have a -4 charge. We know that has to equal 0, so what is the charge on that titanium? Well, it has to be +4. And so since there is only one titanium, we know that it is a titanium +4 cation. So we would name that as titanium 4 Roman numeral chloride. Okay, what about CrO3? Okay, we know that oxygen is a -2. We know that there's 3 of them, so that's going to be a -6 overall. So we know that has to equal 0, and since there's only one chromium cation, what is that going to be? Well, we know that has to be a +6. So this is hexavalent chromium, so this is chromium 6 oxide. And here's one additional compound, iron Fe3N2. Okay, so let's figure out what we can do here. So we know that nitrogen is a -3 anion. We know that there's 2 of them, so overall that's going to be -6. So we know that that has to be a +6 coming from the cations to equal 0. There are 3 irons, so we know we can divide that charge by 3 to give us a +2. So this is iron 2 nitride.